online peak identification can be enabled to identify peaks in spectra as they are required. To demonstrate this, we will use a sample of brass, and we'll start by configuring the peak identification parameters. As the sample is brass, we'll look for copper and zinc peaks, and we'll just look for neutrals and first ionics, and we'll set the minimum intensity to be 100. To enable online identification, this checkbox needs to be ticked. Once the parameters have been configured and online identification enabled, the peak identification module can be closed. We can then acquire spectra using libsoft in the normal way. So if we look at the acquisition configuration, we're going to use 20 conditioning shots and 10 accumulation shots, 1 spectrum and 1 measurement, and we'll save the spectrum using the sample name of brass. The laser is configured to fire at 5 Hz with a Q-switch delay of 150 microseconds, which equates to approximately 50 millijoules for this laser. And the spectrometer is configured with an integration time of 30 microseconds and an integration delay of 3 microseconds. We can then initiate the acquisition. So the laser flash lamp is started. Conditioning shots are fired, and they're followed by the acquisition shots. The spectrum is displayed and is analysed on completion of the acquisition, and any peaks identified using the current configuration are annotated, so we can see that a number of peaks have been annotated. Note that for online identification, a peak threshold value is automatically calculated based on the acquired spectral data in order to identify a reasonable number of the most intense peaks in the acquired spectrum. The software attempts to set a threshold value such that at least 5 peaks are identified if possible, but the maximum number of peaks identified is limited to 20 so that the spectrum display does not become too cluttered. Note also that online identification is intended to provide a simple indication of the major peaks in the spectrum. If further, more detailed analysis is required using, for example, a user-specified peak threshold, or the selection of different elements for identification, the acquired spectrum can be loaded directly into the peak identification module. In fact, if we open the peak identification module, that spectrum that we've just acquired is automatically loaded, and we can see where the peak threshold has been set, and we can adjust this to identify more peaks if required. And we can see more peaks are identified at this lower wavelength range. Both copper and zinc peaks. The peaks that have been marked but not identified at this higher wavelength range are almost all due to the argon purge gas that was used when we acquired the spectrum.